Hello everyone. Again we are back with the another concept, that is how to measure the op-amp parameters. Now what are the op-amp parameters? So since we have already discussed the op-amp parameters, nothing but the op-amp characteristics. Some of the characteristics if I mention, then it is output impedance, input impedance, bandwidth, common mode rejection ratio, power supply rejection ratio, slew rate, and so on. And also we have seen what are the ideal and practical values of those parameters. Furthermore, we have discussed about the DC characteristic parameters and also the AC characteristic parameters, which means how the op-amp circuits will respond for the AC signal as well as the DC signal. And also some compensation techniques is also discussed in order to obtain the stability if you use the open loop op amp in some applications like linear applications or high frequency applications. Now in today's video we have discussing some of the parameters and what is the procedure of measuring that op amp parameters. So if you observe, I am considering some of the parameters of operation amplifier. That is, the first one is the measurement of slew rate, and the second one is the measurement of common mode rejection ratio. Next, the measurement of output offset voltage. Fourth one is the measurement of input offset voltage and power supply rejection ratio. And the fifth one is the measurement of input bias current and input offset current. And the sixth one is measurement of the open loop gain. So these are the some of the op-amp parameters I have considered and how it is measured if you are considering an op-amp circuit. Since we have already discussed how to measure the slew rate. So in the previous video we have seen what is slew rate and how the waveform of slew rate will be and how to derive the slew rate equation for a particular application circuit. So here the slew rate is measured with the help of considering a voltage follower application circuit, and this is also discussed previously. Now in this video we are going to see how to measure the common mode rejection ratio of particular op-amp circuit. So in this video we are considering a simple op-amp circuit. From that op-amp circuit we have to find out what is the common mode rejection ratio. Now let us see how to measure the CMRR value for the particular op-amp circuit. Before that, let us see what is the mathematical expression of CMRR. So the CMRR full form is or acronym is common mode rejection ratio, and it is mathematically defined as the ratio of differential mode gain to the common mode gain, and the CMRR value is always positive, which is nothing but it is greater than 0. So mathematically I am considering this as magnitude. Okay, so let us consider one example circuit of operational amplifier. So let us draw the circuit. Since the op amp is having two inputs, one is an inverting input and second one is a non-inverting input, and here in order to find out the CMRR value for this particular circuit, we have to assume that the two inputs are applied with the same signal, since we have to find out the common mode signal. So that's why I am considering these two inputs is applied to a single source, that is the input signal Vs. Okay, and let us consider this as a resistor Rf, and it is also Rf, R1 and R1. Now let us name these points as X and Y. Okay, so here the common mode signal is nothing but the Vs value. Okay, now from this circuit we have to find out the differential mode gain AD and the common mode gain AC. Now since a common mode signal nothing but a same signal is applied to both the inputs of operational amplifier, then we can say that this circuit is a common mode term. Okay, from this we can write the value of AC, nothing but common mode gain, as ratio of output voltage to the common mode signal, and here the common mode signal is nothing but the Vs value. So AC is V0 by Vs. Let us consider this as an equation 1. Now from this equation we know what is the value of AC. Now let us find out what is the value of AD. So here the differential mode gain AD is nothing but the ratio of output voltage to the differential input voltage. Now what is the differential input voltage? This VD is nothing but the difference of X and Y voltages. Okay. So this indicates the VD value. So I can write the differential voltage expression mathematically as VD is equal to non-inverting input potential minus inverting input potential. Here I am considering a non-inverting terminal as Y and inverting terminal is named as X. So I can write VD expression as Vy minus Vx. Okay. Now we have to find out the values of Vy and Vx. Thereafter substitute in the value of Vd, and next the value of Vd is substituted in terms of in AD. Okay. Let us consider this as equation 3. Okay. Now from the circuit we have to find out the values of Vy and Vx. Now how we are going to find out is easy simple calculation is simply apply the nodal analysis. Okay. So I am applying nodal analysis at X node. Okay. So simply apply nodal analysis at X node. So we can write it as Vx minus, now what is other potential? It is Vs by R1 plus Vx minus V0 by Rf is equal to 0. Now take the common Vx, then it is 1 by R1 plus 1 by Rf, and which is equal to Vs by R1 plus V0 by Rf. Now take the LCM. Then it is Vx into Rf plus R1 by R1 Rf, which is equal to Vs Rf plus V0 R1 by R1 Rf. Now these two will get cancelled. So finally the Vx value we have found is Vx is equal to Vs into Rf plus V0 into R1 by R1 plus Rf. Now this is the value of Vx. Let us consider this as equation 4. Now next step is we have to find out the value of Vy. Now at this point we can find the value of Vy with the two methods. One is simply applying a nodal analysis as we did in the X node, and the other one is simply applying the voltage division rule. Okay, either of the method you can use. I am using a simple method, that is apply nodal analysis at Y node. So if you apply nodal analysis, then it is Vy minus Vs by R1 plus Vy by Rf is equal to 0. Now take the common Vy. So if I take the common, Vy is 1 by R1 plus 1 by Rf, which is equal to Vs by R1. Now take the LCM, then it is Vy into Rf plus R1 by R1 Rf, which is equal to Vs by R1. Now R1 gets cancelled. So finally the value of Vy as Vy is equal to Vs by, what is the equation? It is R1 plus Rf. So Vs into Rf by R1 plus Rf. Now consider this as equation 5. So from this we have find the value of Vx and Vy. So substitute the values of 4 and 5 in 3. So if you write, then Vd is equal to Vy minus Vx. So now what is the value of Vy? It is Vs into Rf by R1 plus Rf minus, now what is the value of Vx? So Vx is equal to Vs into Rf plus V0 into R1 by R1 plus Rf. Now take 1 by R1 plus Rf common, then it is Vs into Rf minus Vs into Rf minus V0 into R1. So these two will get cancelled. So finally Vd is equal to minus V0 into R1 by R1 plus Rf. Therefore V0 by Vd I can write as minus R1 plus Rf by R1. So if you write in simple equation, then I write AD, which is equal to V0 by Vd, so which is minus of 1 plus Rf by R1. Okay, so this is the final value of AD. Let us consider this as an equation 6. Now substitute equation 6 and equation 1 in CMRR formula. Then we will get the common mode rejection ratio rho is equal to magnitude of AD by AC. So now what is the value of AD? It is 1 plus RF by R1, and the AC value is finally finding out V0 by Vs. Okay. So this is the procedure how to find out the common mode rejection ratio for the particular op amp circuit. Thank you.